Let's go ahead and get started. So I just wanted to bring to everybody's attention that there's a call for presentations for the APEC Summit. Deadline is May 18th to call for presentation. And then the week of June 15th, the speakers will be notified. And then on July 6th, the draft presentations are due. And then August 3rd, the final presentations are due. Also, to what's kind of happening to this group, I think, is a little bit up in the air. We've had this discussion about moving us under the AI continuum. I'm not quite sure what's happening. I kind of noticed today that stuff is kind of being shuffled around on the main web pages in terms of projects. So stay tuned. If I find out any information, I'll send it out to the mailing list. Does anybody have any questions on either the summit or kind of this move to the AI Continuum project?
No, but just to confirm, because we're not hearing you all so loud, John.
Right. Is this better now?
A little bit, yeah.
Is this any better? No, I got echo.
Better. You have an echo.
Yeah. Let me try one more thing here.
Oh, that sounds better.
How about now? Is this any better?
Yes.
That's better? Okay.
Yep.
All right. So let me just repeat. So there's a call for presentations from the foundation for the Apex Summit. May 18th is the deadline for submitting a proposal. Then the week of June 15th, the speakers will be notified. And then on July 6th, draft presentations are due. And then on August 3rd, final presentations are due. So that kind of is one of the kind of things from the foundation. The other thing is that kind of the status of our group is a bit up in the air. They're wanting to move us into this AI continuum project. So if I find out anything more, I will send information out to the mailing list. Let everybody know kind of what's happening. Because the telco aspect, I think, has been kind of disintegrated, and then they wanted to kind of move this edge underneath that umbrella, but it looks like it's kind of in progress, but it's not quite clear yet exactly what's going to happen. So those are the two things I had. Does anybody have any questions on those?
Yeah, I think just one thing as I'm kind of re-entrenching, and I was looking at some of the presentations under the data center MHS, modular hardware system.
Right.
I don't know, it would kind of seem, and I think that was part of what I was emailing you and Kevin about this morning, that it kind of looks a little bit more like we'd be oriented into that type of group and that set of discussions than
if you look
AI
at this
continuum.
Well, if you look at this AI continuum, underneath that is this thing about MHS.
Hmm. Okay.
Let me see. Maybe I can quickly if this works. Da, da, da. Let me try to share my screen here. Go to the others. All right, so if you look over here, you guys see my screen now?
Yeah.
All right, so if we look under projects, uh, this AI continuum, you'll see here
Hmm.
this edge native AI
Oh,
edge native MHS.
okay.
But if you look there, it's kind of getting started. And yes, I don't know how we would kind of blend with what we're doing into this, but I think that was somewhat along the lines of what the thinking was.
Well, yeah, David Heinrich, because I was just looking that up, he's HPE. And I mean, in the group, I've seen like one of the presentations they did with the data center MHS. You had Dirk Blevins from Intel, Rob Nance from Jabil, Greg Selman from AMD, David Heinrich, and John Lewis from Dell.
Yeah,
I mean, I guess the fact that they're now plugging it into an AI-oriented system, well, I'm curious about that.
in which way? Like what? Why they hung it under there?
Oh, and that it's not all, I mean, AI, but I guess AI native edge. Maybe you could share.
Yeah,
I
I think
don't
I think they're floating it under the AI banner because that's the current buzz of the day,
know.
and this group's kind of struggled for participation because it was hidden under the telco side. So
Yeah,
it's kind of funny where you hang these things. It kind of impacts participation. Um,
sure.
and so where we suffered kind of being stuck under telco was everybody had this assumption, oh, this had to just be telco, right? And we've been trying to expand the scope and not just tie ourselves to telco. It really should be something like harsh environments, right? We're kind of looking at taking this stuff out of the data center,
Mhm.
looking at having this all work in a a more restrictive environment. And so that's really what it is. But because it got stuck in your telco, it gets kind of branded with, oh, well, if it's not what I want to do is specifically telco, then I don't think I could fit here, but you can.
Mhm.
And so the same thing I think is gonna kind of happen with sticking with their AI continuum, because it's gonna be like, well, this isn't really AI, it's just ruggedized hardware. Um, but it may end up with the same problem because people won't find it because they wouldn't think to look under AI, because that's not specifically, maybe
Yeah.
it's a use case for it, but it's not complete for why you would need a ruggedized environment. But
Well, would you want to kind of click on the wiki and see what that kind of says there?
so this is kind of coming out of, I think this is kind of spun out of the MHS project.
Yeah.
um because it had we've had some connections back and forth with the MHS, because they started something called the MHS Edge project, and it kind of coupled with what we were doing, and so like Dirk and I have been interacting,
Yep.
um, and that kind of thing. So we're I think we're trying to figure out how to best put this together so that it fosters a greater community and participation.
Mhm.
And so maybe moving it up from telco under AI is just going to be another problem, but in another another domain. We'll see. Um, but yeah, so
Well,
it may not be the perfect fit either, but at least maybe it might get a little more buzz and interest. But we'll see.
Yeah, I'm happy to take a look deeper. I've known Dirk for a while, and you know,
Yeah, he did a we did a presentation several months ago now, talking about this, how we can kind of bring the groups together and kind of fold it up under that AI continuum.
yeah, because it looks like and that's part of. Let me see, there was a presentation I was watching yesterday. It was from a couple years ago, and they were talking about a lot of smaller form factor product, and actually they showed an image of a 2U high system, and it was using some pretty narrow power supplies, and which is what, I've kind of honed in on power supplies, battery backup, and more traditional 19-inch oriented hardware. So it looked extremely similar to the Nokia system that I remember being involved with a number of years ago, which
Mm-hmm.
was the Telco Edge product.
Right. Yeah, and it's
And
funny that the history of just to kind of give you a little history on that one. So kind of that whole specification, like the dimensions and everything, actually kind of were derived from um, a piece of like a homegrown piece of equipment that already Nokia had that was already out on
yeah,
these edge sites, right? So the idea was is to just kind of make that interchangeable. There's
right.
nothing magic about why that was those sizes. That was just what was proposed back at that time because it would be like a drop-in replacement
Uh-huh.
from a dimensioning perspective. And then it's kind of funny because some people took that and just ran with it,
Yep.
and started using it in other places and what have you. So um, it would be good to maybe even relook at all of that, right? Because it wasn't necessarily done, holistically. It was just trying to replace something that already existed,
Hmm.
and kind of fit into the same footprint, dimensions, function, etc. Um, but yeah, so I mean that would be kind of the hope is that we kind of look at broader use cases, come up with something that is more adaptable, than you're just kind of restricting this telco side.
Hmm.
And then the AI thing too, like it doesn't necessarily have to imply AI, right? It's just a form factor.
Well,
Like,
I think you're right, and that's why I was kind of puzzled. I mean, saying I don't necessarily consider this stuff as AI because to me that means that there are GPUs in it, and I think in a lot of these instances there might be some GPUs. And as a matter of fact, what I was looking at in that presentation was, they had some instances where you're going to have a traditional CPU system, and then others where, yeah, you've got it pretty densely packed with a localized GPU.
yeah, yeah.
You know
The
that,
funny thing is what previously was the goal for all of this was like low power, low heat, low cooling requirements. But then the minute you start tossing in GPUs, then it flips that all on its head.
yeah,
Uh, and so, maybe some of the concern is if it implies AI, implies GPUs, then you're going to lose the use cases that don't want that and don't need that. But that's going to be kind of the challenge when you're shuffling this stuff around, right? Is
right.
it kind of gets tainted by whatever this main project is hanging under.
Hmm.
Um, so yeah, I mean, thinking about it now, maybe we're just removing the telco taint and then adding this AI taint to whatever, but that shouldn't necessarily even, it should be an input, but not a complete coloring of everything that probably should be done there, right?
Hmm. Yeah. Well, I think we need to take a closer look at this thing.
Yeah, yeah. So I'll try to find out more information on what the current thought of the day is, because I know things have been kind of waffling and moving around, and it's just kind of unclear exactly what they're trying to do. But yeah, I think you bring up a valid point that we don't maybe necessarily want to constrain it to only AI, because then that has the opposite effect.
Mhm.
But anyway, um, so yeah, how you wanted to kind of run through, um, kind of what we had talked about last month. Are you good to kind of drive that?
Yeah, I mean it's been a busy month, with OCP and in Barcelona, and we Inventus is coming in from the perspective of, we're a custom pack integrator, and we've kind of taken our eye off the ball for the last 5 years in supporting data center oriented applications. So what I'll tell you is, I mean, I have no presentation for today, but just giving kind of an update of what we're trying to take a look at to support. And a major piece is, if we look at the focus hardware in Open Compute, it's the ORv3 systems, and how they have expanded in such a way that you've gone from the ORv2, which was in place 5 years ago, and then the ORv3 with the bus bar and 44 OU height rack solution and rack-based power. So you're doing your AC to DC rectification in the rack, and that means that all of your loads now need to plug into that 50-volt DC bus bar and do DC to DC power conversion for your IT loads. And essentially, Meta drove that in such a way where it was primarily servers in there. And what they also did from a power architecture was they decided that they wanted to have distributed battery backup. So the battery backup was also inside that same IT rack. So kind of funny to think, that was sufficient 4 or 5 years ago, maybe 3 years ago, and even in production today. Um, and then 2 years ago, they said, well, that's not going to be enough. So now we need to go to this HPR, high power rack. So now your power supplies and your BBUs went from 18 kilowatts to 33 kilowatts. And that's kind of where the standard is today, and the 72 kilowatts are on the very near term horizon. So that's for both the power supplies and the battery backup units. And the height is a 1 OU for each one of the power supplies, and it's 2 OU for each one of the battery backup units in that space. So because of the rapid change in power level, a lot of people on the outside didn't adopt it so quickly, because they're saying, well, we don't know when this power ratcheting up is going to stop, for one. And two, there was a limited number of IT servers that were designed around taking a DC input. So you saw a rapid evolvement for the hyperscalers that were going to utilize that type of gear. But for the rest of the industry, they're kind of behind, because there's still plenty of life left in the 19-inch PDU based, what I call 12 volt power architectures. And kind of that's what we're seeing also within edge applications. And then when you go into a telco cabinet, also, I mean, you have other sizes. So, we still have a lot of disparate type of systems that are going to go into an edge location. And I think one of the things we were discussing in our last call here was the demand for the high-speed optical networks in and out of some of the telco type of real estate. And what type of systems are they going to be supporting? So, part of what we're doing from the battery backup perspective is trying to look at what the different voltages are and what the different rack configurations are going to look like. And is there a possibility of developing something that could be somewhat standardized to fit into those environments? So what we were talking about in the last call was my company is looking to develop a 33 kilowatt battery backup unit that is ORV3 HPR oriented. And, that's going to serve, for the most part, fully loaded rack solutions. I don't know how much you would see that in an edge system solution that may only be, 2 or 3 or 4 or 6 U high. So that's kind of one area to take a look at. Because again, edge means all sorts of different things, but there's a smaller systems and the larger systems. So the other thing that has come up over the last month is an application with one of the very major server and data storage companies, what I would consider one of the major enterprise entities. And what we're taking a look at is a 12-volt oriented battery backup unit that would fit into the MCRPS form factor. So that would be a 1 RU high by 73.5 wide and 185 millimeters deep. And we've gotten a lot of positive input about that as an idea. Because for that particular power supply, which is now being adopted by HPE, Dell, and AMD and Lenovo, for that specific MCRPS, there's both a 2400 watt version and a 3200 watt version. So we are taking a look at the possibility of probably the minimum a 2400 watt unit that could support 2 to 3 minutes potentially of runtime. So within MCRPS, there are a couple of different size form factors. The one that's used most predominantly by the networking guys because they don't need as much power is a 60 millimeter wide version of the same thing.
And so the idea is that you could have enough time to shut things down.
Correct. Well, I mean, there's a couple of pieces there. One is for any interim power interrupts. So, think about in your house, you may get like a little flash to give a warning, like something's up in the line, and then it turns back on and then it turns back off a couple of minutes later. So you may see things like that where it's a short interrupt, but the design is really for the time it should take for your more consistent backup power to turn on. So let's say it's a diesel generator, you usually want to have 30 seconds. If there's any type of ATS switch issue or there's any issues, you want to have more than that. And also what you do is you control it to say, all right, well, let's say at 30 seconds, if the backup power hasn't turned on, then you would go into shutdown mode. So it would give enough time to do a graceful shutdown.
Okay.
And we would be designing this to be able to run multiple BBUs in parallel based on either higher power loads or longer runtime needs. So that's kind of the other reason why I really would like to look into these different form factors to see which power supplies are being used in each one to determine if there's any type of overlap or any common thread. And then the other piece, yeah, I mean, the other piece of it that's obviously different is that you don't have an AC input on on this. So you are also having to change your, I mean, you can use the same connector style, but you're going to have a different connector interface, obviously, because you're going to need your input DC power to charge the battery in the first place. But your output piece of it should be about the same. And then we're also trying to identify what is some of the functionality of the power supply that some of the designers are using that we would also need to incorporate into the BBU. So, there's a level of communication. There are elements of cybersecurity that go into the power supply, which we may or may not have to have. Hard to say. Just depends on how you locate that BBU within your system.
So how would you orchestrate this changeover from, maybe your diesel backup coming online, but it's taking longer?
So there is, from what I understand of the initial designer, Aurelio Rodriguez, who used to be with Intel and now he's at AMD, that the MCRPS module and firmware supports the power pin to know that there's an issue.
Oh, okay.
And then, there's an element of timing. So yeah, there's some programmability and communication within the power supply to start with.
To kind of coordinate this handover from kind of this
Yeah,
immediate interim to kind of a longer term backup, and then finally once the main comes
yes.
back.
Yeah, exactly. Because essentially we would have to build that into the battery backup unit, that there's that level of communication to transmit out to the system to say, okay, I'm still running.
So you need to have some type of overall orchestration controlling this.
Hmm.
How long would a system like this be powered off of the capacitors?
Well, the capacitors from what? The power supply?
Well, capacitor bank in it, and you said capacitors in the BBU,
We may have some capacitors in there, but no, this is primarily a battery.
but the capacitors would just be for millisecond or something
Yeah,
like that. Okay.
yeah. I mean, the normal power supply is going to be somewhere between 12 and 20 milliseconds of holdup time. So that is enough time for the battery to engage. So we have to, determine what is that catalyst. So in the original ORV3 um, version that's connected to a bus bar, basically your power supplies were running at 50 volts and then the batteries were running at 48. So if you had a voltage drop on the bus bar, at 48 or below, then they would engage. But in the newer systems, there actually is a communication link to show that power is dropped and the batteries can then engage quickly. So in this case, we would have to ensure that the batteries have the communication with the rest of the system, that they are now operating and powering the system. And here's your clock as to how much more you can run. Because that's going to be based on state of charge, temperature, power load. I mean, there's all sorts of different factors to say how much time are you going to have left within that BBU.
And how long would the BBU run if the generator doesn't start?
Well, we would have it's very much based on the choice of cell
And how
and
much you
the size
spend?
of the package. So
Give me a range.
let's say 2 to 3 minutes.
Okay.
Yeah. Yeah, that's usually, I mean, if you go into the spec for an ORV3 BBU, it's 4 minutes at like 65% power and 90 seconds at full power, I believe it comes out to. But again, it's different application. So in this case, I think we're going to try to determine how much can we get out of that common form factor size. And it's also something where we put that specification on when is the end of system life. So we lose anywhere from 7 to 10% of the battery capacity per year because it's sitting in a hot environment. And these are even using the best cells. So we try to do is say, well, let's say it's 5-year life. And then we calculate how many cells we need to put in the system based on essentially the requirement runtime at the end of that life. So let's say that we determine that 3 minutes is sufficient, and likely at the start of installation, you'll be more like 5 minutes.
Does the controller in the BBU have management information available for what the estimated runtime is?
Mm-hmm. Yeah. Yeah, that's that's all in the battery gauge, temperature. Yeah, I mean, there's essentially a small micro in there that will be calculating all of this.
That talks redfish?
I don't know if this one would be redfish in an edge application. The one in the 33 kilowatt, the whole system, yeah, absolutely. So we would have an offering of either something a little bit more dedicated, it's a power management module, or the PMC, the power management controller, has a redfish capability in it. But I don't know in this smaller edge 12-volt system. That may be more than is really needed in that instance.
So when it starts to encroach on its lifetime and you have to replace the cells, what does that kind of look like? Is that like rip everything out and replace the whole thing, or do you can you rip out parts that are degraded versus other ones?
In which system are we talking about? Say a smaller 12-volt traditional architecture, or a full rack?
Yeah, I'm thinking I'm thinking like if you built a large, you had maybe a large edge site, so
Yeah.
you had, quite a large battery
Mhm.
backup piece to this, and then as it starts to degrade, you need to upgrade it, or you'll replace
You would,
the degraded units.
so it's going to be a modular system. It's going to look just like the power supplies. So you're going to have 6 BBUs and a shelf. So, if you deem that the shelf should be fine, which there really shouldn't be any type of issues there, you can just, it should be hot swappable, and you can just replace your BBU modules in the shelf.
Okay.
Yeah. Yeah, we plan on making that one pretty much the same as the ones that are supplied today by Panasonic and Delta. And the reason that there's a niche for us is that they are extremely focused on supporting the major hyperscale customers, and they are not really interested in supporting small volume project-based applications.
So, like, would your solution kind of fit that telco paradigm where they want to put this, at these tower sites? Would that be
Yes.
kind of a space you'd try to fill? Because yeah, what you're
Yes.
describing, I see a lot too with the networking side of things. Is everybody's focused on the hyperscalers, but there's things as you move out that is kind of an unmet
Mhm.
market there. Especially if people are wanting to start to do this kind of more distributed
Mhm.
types of deployments and in these
Yeah.
harsh environments.
And just saying, this is, I'm trying to figure out from the screen. So this is Michael from Invent speaking.
This was John.
John, okay. Um, yeah, because you have a mute on yours with a John on OCP, and then
Yeah, I'm on my phone. I'm actually on my phone because I'm having trouble with the Bluetooth thing.
yeah, okay.
So
Um,
like with the
yeah,
OCP.
so right. So the way that this would work, John, um, and the reason I brought up Invent there, Michael, is I'm having conversations with a bunch of people on your team, in your organization, um, because it's also being looked at. This 33 kilowatt BBU is something that can be supportive of some of the liquid cooling systems as well. Because when you get into some of the larger scale liquid cooling, they're using the ORV3 power supplies to power the chillers and the fans because they're all 48 volt native motors and they need a redundant input. So there's also that thought of, well, we need in a lot of these newer AI oriented systems to also have backup for the liquid cooling system. So you have that. Um, and supporting the IT rack, yeah, I mean, the 33 kilowatt BBU is modular. So it plugs into the bus bar. So you basically have one input, one output, both for charge and discharge. And then depending on what your load is, you can determine how many modules you want to plug in. Each one is going to be 5.5 kilowatts. And it is a DC regulated output of 50 volts. I could probably show a picture of that. Or maybe in the next meeting, I can share a little bit more of what these things would look like.
Okay.
But if you're coming in from the perspective of the power supply world and you're familiar with the traditional servers per se, or anything that goes into that ORV3 rack, yeah, it doesn't look any different. I mean, that's kind of the premise.
The question,
Because,
the cell towers are today are often air conditioning or heat exchangers
uh-huh.
with the especially with millimeter wave radios. So but you're talking about liquid cooling in addition to that, or
Well, I'm just saying that liquid cooling is an area where they are incorporating some of the power supplies already that were designed for the IT racks for the servers. And again, that's on the AC to DC, the rectification side, because most of those are set up to support a dual input.
yeah, and the telco side is all DC. There is no AC for the most part.
Right, right. So that would take something a little bit different, coming off of a minus 48 volt. Um, and, what I often see, at least coming from the power supply world the last 5 years, is you would take essentially an AC to DC power supply that is designed to plug directly into your server or your switch, and it would take a DC input. And it really was not the most efficient way of doing it. And it was also a pretty expensive power supply, but it kind of worked. And that's what most people have been using.
Yeah, but my question is, and I asked this in Barcelona meeting to several people, if we're talking about massive rollout over the coming years,
Uh-huh.
why wouldn't the servers just switch entirely to DC and have zero AC involved at the edge? And everybody kind of shrugged and they didn't know, but because it just seems to be more efficient.
It is. And I think it kind of goes to what I was pointing out earlier, that the progression of the power levels and the voltages have been going so fast that I would say some companies get caught in a level of inertia. saying
Yeah.
like, I don't know what I want to really develop because I brought up at Barcelona. I was there as well, and I was talking about because it's the whole power chain here have been very fast to adapt and make these new systems and new voltages and they've been very quick. But the concern has been that the rest of the market that are building off-the-shelf products are slow to respond to these new voltages.
Yeah.
So you're saying that basically the data center is moving quickly, but
Yep.
everything else isn't. Yep.
Right. So the equipment is available to everybody else for power and for, well, limited for battery backup. I would say for power, for the racks, for the bus bars, for the liquid cooling, those are available to the rest of the market. The problem is you don't have many off-the-shelf servers that are designed to take that 48 to 50 volt DC input.
Right, you're right. That doesn't exist today, but I think when it comes to a significant rollout,
Mm-hmm.
that the outside plant engineering leaders are going to look at this before they buy anything and say, "What are you talking about AC? You have to make these DC.
You're right.
We're not going to buy a million of these if it's AC because there's a strong pressure to reduce the power requirements,
Yep.
and the heat management, and
Yeah.
I think it's
Yeah.
just inevitable. But I can't get anyone to at OCP to even entertain this idea.
So I think part of the issue there, Matt, is that when you go to a hyperscaler, let's use Meta as an example. All right. They are the largest customer by far for that type of product. And their servers are going to come customized from whoever their sources are going to be. So let's just say it's Lenovo, for example, or WeWin or Asus or any of these guys. Okay. They basically dropped in a design to them as contract manufacturers to say, all right, this server is going to be DC input native now. And those suppliers then say, well, all right, I already have a big customer for this. And because I would go around over the last few years at all the OCP summits and I would ask some of those suppliers, they'd say, oh, yeah, we're building for Meta. And I said, well, are you offering that as an off-the-shelf standard for the rest of the market? And they just looked at me cross-eyed. And they're like, no, we're not doing that right now. But that's a good idea.
It's kind of a chicken and egg thing, right? Is people buying off the shelf stuff don't necessarily think about it because nobody's offering it. Nobody's offering it because they're not asking for it.
Well, I think what happens then is you get into these conversations like with those neo cloud guys, and there was a presentation last year at the OCP Summit in California about one of the companies saying a lot of pitfalls. They were pointing out these specific areas, saying, yeah, I mean, it's really hard for us to get all the hardware and then to get the hardware to talk to each other. It's still not so straightforward, but if you're in the hyperscale space and you're supplying at that type of volume, the hyperscalers have all the resources to put all the pieces together. So, this is part of what we are looking at. So when we get out into an edge, I think all of us are very realistic to say it's a different customer base, a different set of architects that are going to be putting this together. And it's not a clear-cut solution.
Well, isn't that an ideal place? This group here, isn't this an ideal place to specify and say, for these reasons, we're specifying DC power?
Yeah. Yeah, and these are the type of sources, or these are the options depending on the scale of your system.
Yeah. I
Mhm.
think this is a perfect place for, at least for now, to raise this up, publish something and so people can be aware and say, hey, this is the edge reference architecture. That's what we should call it too, or reference architecture for the edge, because that's the language they use in the hyperscales, reference architectures for every aspect.
Yeah. And I do think that it's good that we've taken, and yes, it is definitely a generational thing, that we've taken it, or we're looking at taking it away from the telco heading.
Yeah.
But the DC-MHS, if it's tied in with that, it seems like there's a lot of momentum in that space. And it also has the right driving companies. And I think that, John, it should be Nokia tied in with the HPEs and Dells who are doing most of the servers out there.
Yeah.
That's for America. If you're talking global, Huawei's got a big role.
This is true, but geopolitical stuff,
Yeah.
unfortunately.
I'm not making a case for
Yeah.
it. I'm just saying
No, I
that's
know.
installed base.
Yeah, right. But yeah, I mean, I visited the Nokia Bell Labs facility, and I was working on a project with them, power systems, over the last few years. And one of the greatest, I think, John, you said you knew him, Charlie Small, maybe?
Doesn't sound familiar.
Michael, uh, whatever it is. I mean, they just said, look, I mean, we're building the stuff that allows, the stuff going in and out of the data center at speed. So, there's a lot to that.
Yes.
Yeah, no, I like this idea. I think this is, maybe this is the right venue, or this team of people. If we roll up under this DCMHS,
Yeah.
or under this Edge MHS, sorry, because I don't think they're specifically looking at some of these things. I'll bring this up with Dirk and those guys, and get their kind of viewpoint and see where we can maybe refit this in.
Sure. Yeah, and I can pull in some people from the power side as well who are already pretty well engaged with that, the DC MHS side of the house. Because there's already sources from all the major power vendors that are also doing the full rack based power. So cool.
Excellent. Well, that was a great kind of wrap up. In terms of kind of what you've been looking at and thinking. I see. Do we have any other thoughts on that?
No, just I don't know how to action a new this idea of creating a reference architecture here, but if you're bringing it up with the other group, then maybe the project leaders can decide the best place to do this work, or even if they want to do it or don't want to do it. I don't know.
Yeah, if somebody can make a contribution, and then I think we got Pedro on the line this month. So Pedro, he's been driving kind of this set of use cases, and I think we've had people provide input last several months on that. It may be perhaps this is a good idea to start kind of a reference architecture.
Hey, yeah, the case are being. Hey guys, yeah, I've been a little away, but yeah, because conflicts on my schedule. But yeah, one of the first cases that I've been looking for is kind of validating there is, I don't know if you guys are familiar with. I can send you guys the link. I will just send you here. There is a Linux Foundation kind of flavor, let's say, the Edge. There's a Linux Foundation Edge, and there are other projects under their belts. And there is a kernel community, which is more specifically for blueprints. So, for example, um, some standards, open edge standards that was already established, for example, guys that use it, the machines, the specifications, the hardware for designing blueprints. So there are lots of blueprints out there. So one of the blueprints that I kind of how I'm helping to design is called Autonomous Agents Network. It's basically everything can be an agent, can be a cell phone, can be a drone, a self-driving car, can be a public camera, whatever stuff has some sort of autonomous intelligence and programmability can be considered an autonomous agent. And there are also guys from the Infinity Edge, which uses like AI into the edge, like GPUs or that kind of stuff. So um, I'm proposing some sort of I call it the multi-SLAD system, in which, let's say, we have 19 inch server in which you have like trays or SLADs, and then we can just um, kind of these LADs contains uh, computer boards for the whole system. So each LAD can contain between 6 or 8 those computer boards cards, for example, and then you can have like multi, not only multi-core or multi nodes, for example, but in one single SLAD. So let's say you have 6 SLAD in a 19-inch server, and you have like 6 cards, let's say. So 6 times 6, you have 36 nodes in a single system. So I'm just talking about like those computer boards in a form factor, a card form factor like 244 pins or 320 20 pins, for example. So you can just kind of switch for whatever brand, whatever type, whatever technology. You can just put everything in there, and also all the processing, all the kind of the supporting layer for getting those boards and SLADs and computing modules to work with. There's a, let's say, a single small motherboard, for example, and you can even switch this too. So the system can be upgraded over time. So that's the kind of thing that I'm being working with and proposing. And there's a document that this document will be upgraded, updated all over. Let me just take it here in my drive, and then I can share it with you guys. So yeah, that's the kind of thing I've been working on. There's already a case for that. Let's say we are planning to deploy CV2X network for connecting things. So this is a 3GPP standard for vehicle to everything network, for example. And with the C, we can just use 5G networks, for example, even private or public ones. So yeah, this case that I'm proposing here, that is specification, this type of hardware, we are just seeking to validate this using specifically this this case, right? So yeah, that would be something that would be really beneficial, because we can have like edge processing all the vehicles and autonomous agents connected to the network. So let's say that you have a drone, and a drone just is delivering your good from the local supermarket, and the drone just detects that there was a car crash in the street. So the drone can just capture this event and send an SOS for whatever emergency services out there. So even if your home camera detected it's connected to the network, so it just sends a SOS, for example. So this is some of the few cases that we are exploring. Let's say we can have like flood detection systems as well, and collision prevention systems, and so whatever possibilities out there, and I think that this multi-SLAD using computer boards, computer modules would be just one of the best things that can happen, because this multi-SLAD offer not only lots of cores but also lots of nodes. So having 36 nodes, yes, just single form factor, 19 inch, is a big deal, really, really big deal.
Hey Pedro, do you still have that link handy for the document that you're contributing with?
Yeah, I'm just opening here right now. Just one
Yeah,
moment,
maybe
please.
if you want to drop that link in the chat.
Yeah, just one moment. Yeah, just getting here. One moment. Okay, the link is in the chat, so you guys can just take a look and then make suggestions as we've been discussing. For example, the use case that we might end it up for the system. So yeah, in the next weeks, I will be updating to improve some of the also the use case with newer diagrams and the architecture as a whole. So yeah, and even theoretical calculations on the possible expected workload for this. For example, let's say if you install the system into a pole, there's those outdoor racks for poles, like electrical poles in the even the streets, or even from the semaphore systems. For example, we can just install the system there, and it can kind of process, do a high scale processing for the, I don't know, maybe 1 square, 2 squares, for example. We can just kind of take how many street cameras, how many smart radars, for example, and the number of the autonomous agents that would be connected to the system, and using data, for example, from the Infinity Edge community as well. They use it to run lots of large language models, small language models, to just process different types of stuff. But yeah, we are intending to use a permissioned network, for example. So every device needs to be registered through the network, so we have a more predictable workflow using this blockchain type of system. This is for the software architecture, surely. So yeah, we can have estimates on how many transactions per second we can have in one system based on the number of autonomous agents connected to it. And again, that can be self-driving cars and etc. And just to be clear, there are medium and big cities in different countries all over using the CV2X standard for, this is more for autonomous vehicles mostly, but we are just kind of reusing the whole structure and the way of working of this standard to just adapt to to what we are proposing, since the 3GPP standard doesn't have like autonomous agents into their belts, into their specifications. But yeah, who knows? Perhaps in the future we can just propose this for the consortium. And yeah, we strongly believe that having this this blade system using computer computer boards modules that can be attached to the sled system, that would be just really a real game changer, because we can use like CPU or GPU systems into those card form factors, as NVIDIA and any other players out there. Those have those kind of cards that can be used, and they are hugely multi-core systems and whatnot.
Sounds good. Well, it looks like we're at the top of the hour, so we're running a little bit over. But I appreciate everybody's input, and I'll reach out to folks and get some feeling on maybe taking this proposal up, putting together a reference architecture, and seeing how this would blend into however they're rejiggering all of these groups now. So, with that, I guess I'll let everybody go, and we'll talk again next month. Thanks, everybody.
Thank you.
Thanks, everybody.
All right.
Hey guys,
Bye-bye.
bye. Thank you.